Hello friends. This video is brought to you by mywayteaching.com.
Hello friends. Today we will learn about work and energy. In this chapter we will learn work and its unit, energy and its unit, different form of energy, power and its unit, transformation of energy, and law of conservation of energy. So let us start this chapter in detail. In this chapter we will study about the work and energy. Let us try to understand what is the work. Whenever a force makes a body move, then work is said to be done. For doing work, energy is required. When work is done, an equal amount of energy is used up. So in ordinary language, the word work means almost any physical or mental activity, but in physics it has only one meaning. Work is done when a force produces motion. For example, let us take an engine. When an engine applies force on a train, the train moves. So work is said to be done by engine. Let us take another example. When a horse apply force on the cart as shown on the screen, the cart moves. So work is said to be done by horse. Now we know that what is work. The work done by a force on a body depends on two factors. Let us take a box. When a force F moves a body by a distance S, that is from initial position to final position, that is total distance traveled is S from initial position to final position. That means the work done by a force on a body depends on two factors. One is magnitude of the force and the distance through which the body moves. So the work done is equal to the force into distance. F indicates the force and S indicates the distance, that is the distance traveled from initial position to the final position. So the work done in moving a body is equal to the product of force and the displacement of the body in the direction of force. When a body is moved on the ground by applying force, then the work is done against friction. So we know that work is the product of force and distance. Now the unit of force is Newton and that of distance is meter. So the unit of work is Newton meter. We can also define the unit of work. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, then the work done is known as 1 joule. So 1 joule equal to 1 Newton into 1 meter. So J denotes to joule and N denotes the force Newton and M denotes the meter. So the 1 joule equal to 1 Newton meter. So the SI unit of the work is joule, which is denoted by the letter J. Work is a scalar quantity. Kindly note that the condition for a force to do work is that it should produce motion in an object. We know that the condition for a force to do work is that it should produce motion in an object. That's it. It should make the object move through some distance. If, however, the distance moved is 0, then the work done on the object is always 0. For example, on the screen, when a force is applied to the wall does not move. So no work done on the wall. That means a man may get completely exhausted in trying to push a stationary wall, but since there is no displacement, the wall does not move. The work done by the man on the wall is 0. However, the work done on the body of the man himself is not 0. This is because when the man pushes the wall, his muscles are stretched and blood is displaced to the strained muscles more rapidly. These changes consume energy and the man feels tired. Now let us take one more example. A man standing still at a bus stop with heavy suitcase in his hands may get tired soon, but he does no work in this situation. This is because the suitcase held by the man do not move at all. That means it is clear that it is not necessary that whenever a force is applied to an object, then work is done. Work done only when a force is able to move the object. If the object does not move on applying force, no work is done at all.